let's go to page 28, and this is section 3.4. This is to solve word problems. Now normally you would do the 3 steps. First, you define all the variables. Step 2, write all the equations by translating the sentences, and then you solve the equations. So let's go to example 3-10. So first read through, it says Johnny is twice as old as Gina. And normally if you use the same letter as the beginning of each word, then that way the variable would be very obvious. So that way when you translate, it would be easier to translate. So Johnny, so that's J, so that's Johnny. Is means equal, twice means 2 times, as old as Gina. Okay. So by doing this, your variable would be kind of self-explanatory. And next sentence is a Johnny, so that's J. Is means equal, 5 means 5. Years older means plus, years older than Gina. Okay. Now, if this is the H problem, so if the H problem is a little bit complicated, then what you need to do is make a table to keep track of your information. But this problem is so easy, you can just translate. And now you can go ahead and you can substitute either way. Okay? So you can substitute, so J equal to 2G, so you can substitute into here, or you can substitute this in, it doesn't matter. So J equal to 2G, so 2G equal to 5 plus G, and then your minus G on each side, so you got G equal to 5. Then after that, go back and answer the question. It asks, how old is Johnny? So you're looking for J. So Johnny is 2 times 5. So Johnny is 10 years old. Okay. Let's go to example 11, 3:11. So read through the problem. So this is the digit problem, and with the digit reversal. So the way to set up a problem is you set up the original number, has 2 digits, so it'll be 10th digit, unit digit. And then you switch the digit to get a new number. So the new number is from switching the digits. So unit digit at the 10th place and 10th digit at the unit place. So now you can go and translate. So it says the unit digit, so that's U. So unit digit is, so equal 3 times the 10th digit. Okay, so that's the first one. Now you said digits are reversed, so that's how you get a new number. It says the resulting number, so the resulting number is a new number. So the new number, that's a resulting number, is, means equal, 54 more than the original number. Okay. Now, so again, when you're doing the translation, just do the translation only. Okay, and then after you can worry about substituting the variable and stuff like that. So new number. Now the numbers have the value. So this was 10. So this it would be 10U plus T. Now original number would be 10T plus U, because the T is a 10th position. So we have to multiply by 10 because it was 10. Okay, so now you can go and substitute. So U equal to 3T. So U equal to 3T. You can go and substitute. Okay, so U is 3T. And after that, you can go and simplify and you can solve. Okay, so you got 30T plus T equal to 54 plus 13T. And so I'm going to minus 13T on both sides. So I got 18T equal to 54. Divide by 18, so T equal to 3. Now, nice thing about digit problem is that the answer should come out nice decimals. If not, integer. So if not, then you know the answer is wrong. Okay. So now you can come up here, look for the unit digit. So now you have to go and answer the question. I kind of circle those intermediate answers just so that easy to find those information. And it asks you find the original number, So original number would be 10th digit and unit digit, so it would be 39. So original number is equal to 39. Okay, let's go to example 312. So read through the problem. So this is the motion problem. The motion problem, the key equation to remember is R, the rate times time equal to distance. Okay. So anyway, so you want to draw the picture. So here's Jim, and here's Mom's house. So Jim drove to Mother's house, which is 40 miles away. And then drove back. Okay. And on the way there, so now when you come back, the distance stays the same, right? So on the way there, he drove 40 miles an hour. So the rate equal to 40 miles per hour. But on the way back, only 20 miles per hour. So what's the average speed for the whole trip? Now average speed, so the rate is equal to distance divided by time. So the rate equal to distance divided by time. Okay, so that's the speed. Now for the whole trip, you can just kind of average the 40 and the 20. It doesn't work that way. Okay, so the whole distance is 40 miles that way, 40 miles come back. So the distance is 80 miles. And the time, so if you notice that it's 40 miles per hour, and so you go and drove for 40 miles. So this one, the time equal to 1 hour. Over here, it's 40 miles, and he drove at 20 miles per hour. So this one, time equal to 2 hours. Right? So R times time equal to distance. R times time equal to distance. So 1 hour going, 2 hours coming back. So total time would be 3 hours. So the rate, so the average speed for the whole trip is 80/3 miles per hour, or 26 2/3 miles per hour. Okay, let's go to the next example, 3-13. So this one, so a frog swims 8 miles downstream, and in 2 hours. So you can downstream, so you draw the arrow down, and she returned upstream in 14 hours. So you can the same distance, and this would be 14 hours. Now here's the water is going down. So how fast does the frog swim in the still water? So you're looking for the speed of the frog. Okay, so sometimes it helps if you draw the table to help you to. So this is down, and this is up, and this is R times time equal to distance. So downstream is going to be the rate of the frog plus the water is going, and the time is 2 hours, and the distance is 8. When you're going upstream, the speed would be the frog minus the water, because the water is going to push it back, and the time is 14 hours, and the distance is 8. So you have two equations over here. Okay, so you have F plus W times 2 equal to 8, and you have F minus W times 14 equal to 8. So what you can do is, it's easier if you just divide by 2. So you got F plus W equal to 4, and you divide by 14. And then what you do is you can put this underneath here, and you can, because the W is already opposite already, so you can go ahead and eliminate. Okay, so put underneath. So they cancel out, so you got 2F equal to, now this is equal to, so I'm going to simplify this, so this would be equal to 4 over 7 divided by 2. And so I'm going to make in the common denominator, so they become 28. So when I add, I get 32 over 7. And then after that, I'm going to solve for the frog speed, so I'm times it by 1/2. So the F equal to 16 over 7 miles per hour. Now it does not ask you for the water, but if you want to solve for water, it would be very simple. You just go and substitute into either this equation or this equation, and you can find the speed of the water. Okay, let's go to example 14. Okay, so read through. So this is the work problem. So you got 2 pipes. So it's better to go ahead and make a table to keep track of your information. So this is pipe A, this is pipe B. So this is the time, and this is the rate per hour. Okay, and this is together. Okay, so a pipe A can fill the pool in 5 hours. So the rate would be 1/5, right? 1/5. This is how much it can fill up in 1 hour. So it'd be just reciprocal of that. And B can fill in 4, so 1/4. So how long will it take for the 2 to fill if they operate at the same time? Okay. Okay. So together it would be X. So you don't know what the time is, so reciprocal that would be 1/x. So here's your equation. When you write this, you need to go and use the rate as your equation. So you got 1/5 plus 1/4 will equal to, another way to do it is just multiply by time. So this is how much per hour, this is how much per hour, and you need to times by amount of time, and this will equal to 100% of the job. Or you can do it this way. Okay? So this is quite easier to understand. Okay? So if you're not used to this, you can just forget about that. Just do this. So again, this is how much fill up by pipe A in 1 hour, how much fill up by pipe B in 1 hour. So work together, this is how much in 1 hour, times by number of hours, this will fill up 1 pool. Okay, so 1 stands for 100% of whatever the job is. Okay, so now all you have to do is go and solve, right? So X times, so you can add this together. Now to solve this, you multiply by the reciprocal. So this will cancel, so X equal to 20/9. And the time would be hours. Okay, so let's go and do the example 315. So again, this is the work problem. So this is the time, and this is the rate. So you got 3 people. So you have the time, you have the Huck, and the Jim. So this one, they didn't give you the time, so you just use a variable, so it'd be T, and you have the H, and you have the J. So the rate would be 1/T, 1/H, 1/J. Right? So again, this is how long it take, and so This is how much get done in 1 hour. So all you have to do is go and translate. So time and hug, so it'll be 1/t plus 1/h. Okay, so time and hug, painting the fence for 4 hours, so times it by 4. After which Jim help them and finish 2 hours later. Okay, so 2 hours when all three of them work together. And this will equal to 100% of the job, or one job. Okay, or equal to one fence. Now it says, if Jim have not helped them, it would take them 5 more hours to paint the fence. Okay. So if Jim didn't help, then it would take 5 more hours. Okay. So that means okay. So let's go ahead and work this one. So if Jim didn't help, it would take 5 more hours. It means total would be 9 hours. Okay. So again, if Jim did not help, if only 2 of them work together, it would take 9 hours. So another way to do it is 9 hours if only 2 of them work together. Okay. So again, two of them work 4 hours already. So if Jim jumped in, it would take 2 hours. If Jim did not help, it would take another 5 hours, which means given total of 9 hours. Okay. And so you go and divide by 9, so you got 1/t plus 1/h is equal to 1/9. So what we can do is you can substitute this into here, and you can solve for j already. Okay. So substitute in here, so you got 4 times 1/9 plus 2 times 1/9 plus 1/j equal to 1. Okay, so now you can, so this is 4/9 plus 2/9 plus 2/j equal to 1. So you can minus 6/9. So you got 2/j, 6/9. So you're going to j equal to 3/9. And then you solve for j. You can you can go and do this, simplify, and you can cross multiply. So j equal to 6 hours. Okay, so Jim can do the whole thing by himself in 6 hours. Okay, so let's make sure that, let's double check how long it would take for Jim to paint the fence along. Yeah, so you're looking for j. So whenever you solve for the variable, you always go back and you check, see if that is the final answer they're asking for.